Okay, friends, I think we're back. Are we back? Plugged into the wall again? Yes, we are live. Okay, pause that. So, uh, bad news. I uh, I went and ran the cable out into the other room. Turns out that I'm like 10 feet short of being able to plug straight into the router. So my super long cable is not super long enough. um, so that is just not going to work, unfortunately. So what I did is I ran it on back, plugged it back in here, so we're wired in again. Break the wall. Amazing. Yeah, I mean that'd probably give me another like 5 feet. Maybe it's enough. Um, yeah. So what I did do, I have disconnected my Wi-Fi router in the other room, and I've plugged the Philips Hue bridge straight into the wall. And so my guess is that both of those should be running on the same subnet out to like my apartment or my townhome complex. I think. So that's what I'm going to test now. So let's switch back over to here. Um, and yeah, I am like really hoping that we get different results from this part. So let's go back into here. We'll say node create user. Make that one click bigger. Okay, so that gave me a totally different IP address, right? 140. What if we run it again? Man. Okay, what if I have config grep for inet? Run a 10.0 subnet. Okay, so I mean like E host down. That's kind of weird. What if we run it again? We're just war driving. 140. Okay. Run it again, like a crazy person. All right, let's try this one. So I'll check that in there to my .env file. Go back to the server, source, the .env file, and then start. Oh, and npm run serve will start up the server without building, so I should just be running that. Nah, this looks like we're out of luck. Yeah, this is just going to time out again. Okay. So let's try this other one. I don't see how it's going to be this one because it's not even on the same like prefix. Wouldn't this have been a problem before? Like maybe I was always streaming from Wi-Fi last time. Like when I did light blocks, I was always streaming from Wi-Fi. Which has its own set of problems, obviously, but net unreached, yeah. Okay, shoot, this is kind of a showstopper. We will not be able to do that part of the show. Oh, well, okay, we won't be able to do that part of the stream anyway. So what can we still do? We're gonna head back over to here. I typed that wrong. I'm gonna scratch these out. Oh, this markdown syntax doesn't know that. I'll pretend that they're done. They're not. We gave up on them. But yeah, we could control modular synth from code. I think we can totally do that. That should be cool. Let's see. I think I also have like the collection of requests that get made to light blocks. So I mean, we could look at that at least. Let's maybe do that. So get requests to control light blocks. Okay, then once we've done that, we're going to control the modular synth, and it's going to be awesome. So let's see, that should be in Insomnia. And I actually do have stuff for work that I would rather not stream, so let me open the program and put that away, and then switch back to my screen. Give me just a second to do that. Dashboard, light blocks. Yes. Okay, cool. We're back. So this is a program called Insomnia. You might be familiar with a similar one called Postman. And this is just a desktop UI that makes it really easy to send HTTP requests. So you can see I've got kind of a collection of them here. I've got the interpreter and all of the one endpoints, right, that have to do with that. You can see it's localhost port 4000, API interpreter run, and then the program ID. That's what that is. And if I run this, obviously it's not going to respond because I can't start my server. But that's what that'll look like. And then we've got a lot of other CRUD operations, essentially. So I can list programs. I can get a single program by its ID with more details. I can create a program by posting. I can edit a program based on its ID. And here are like two examples of that. So those are both put requests. And then I can delete a program by its ID. So all the basic stuff right in here. You can see these, like, if I'm, here's like the response from a previous one that I did. And you can see I created one, the title of the program was called Fun Logic. Its ID turned out to be 5, like the database chose 5 as the next ID. And then this is the default source, right? And this is all XML that Blockly will render as blocks. So that's that. But this run program, this is the one that we care about. So essentially what we would do is we would need to write a little node script or some other language to like make a request to this with a method of post, and then that would trigger a program to start. Now, program might change to different colors. It might have like a whole sequence of things that it does, and it might even have control flow that like loops forever or does all kinds of fancy stuff. But this post essentially just says start doing that. And so what I want to do, and which I will do after the stream apparently, is I'm going to wire up a little script so that I can trigger a few of these from MIDI, right? So here's my DAW once again. I'll have a little clip over here that's like trigger the reddish pattern, or trigger the bluish pattern, or trigger the pattern that looks sort of like police lights, or trigger the pattern that reminds me of underwater, or whatever, that'll all, like, really that will all just be triggering these post requests. So that's how that'll work. Okay, send that thing away. We did this. We accomplished the thing. Let's do some modular stuff. This will be really fun. So first thing I'm gonna do is I'm gonna restart this again. So we've got our loop going. And hopefully you can still hear me fine from like vantage point. I've just moved the mic over here, right? But now we can start to do all kinds of fun stuff. Move random things out of my way. So yeah, this is my modular synth, called a Euro rack format synth. And I don't know how well you can see it from that vantage point. Yeah, I need to get a second camera so I can like look over it. But the synthesizer is made up of a whole bunch of different modules. Each of the modules does one thing. It's very much like code, actually. I'm gonna think of each module like a function that runs code, right? Except instead of being digital and instead of running code, it's all analog, right? And it's moving voltages around through these cables. In order to program it, you connect functions to each other in code, right? You call functions with a modular synth. You plug these modules in. Yo, you can still hear. Okay, glad you can still hear. Thank you. So, how is this making any sound, right? Like, how is this doing what it is doing? So, what happens is you'll remember my DAW has those MIDI nodes, right? So, I should pull those up. Yeah, there we go. So at this point, it's digital. Like these are all just digital messages that say, please play C, and then please play E, and then please play G. C it back down and do it in the right rhythm, with the right volume, but it doesn't actually make any sound, right? And by the way, like for the musicians that are watching this, you're like, I get it, I know. Most of my audience is programmers that might not be as familiar with this, so we're going a little depth with kind of like what's happening here. So these are all digital messages, and they are all getting sent over a wire, a MIDI cable. That's a 5-pin cable that sends these physically, right, like electrons over this. It ends up in one of the modules and is able to kind of translate between the digital world of MIDI and the analog world of the. So as soon as it gets into here, there are two signals that we care about that come out of it. You'll notice that now there's no sound at all. So there are two signals that we care about, and they're called gate and pitch CV. So gate let's see. So you'll notice that I have removed one cable, but I kept one in there, right? So we still have this gate going, and that's basically like a binary sort of signal that says on or off, play a sound or stop playing. That's doing its thing. That goes into this other module here. It's called an IntelliGel Atlantis module, which, if you're into classic synths, there's a synth called the Roland SH101 that this is kind of patterned after. That's cool. But you'll notice that right now it's just playing the same note over and over and over. Okay. Yeah, I can still do some things to the sound. Like, you hear how now it's kind of shorter and pluckier. It sounds a little more like guitar-like, maybe, you know? It's still synth, right? But it's kind of pluckier. I'm changing what's called the envelope. So now I'm changing the envelope back so there's more sustain. So those notes get held out and they don't get quiet all of a sudden. That's doing its thing. Another thing that you can do, and this is all analog at this point, right? Listen to what happens when I change this. You can hear how the synth gets more muffled or it gets more kind of bright sounding, more buzzy. So what I'm doing here is I'm controlling the cutoff frequency of a low-pass filter. What that basically means is there's a circuit that allows the low-frequency sounds, the low sounds, to continue to pass through and end up in the speakers, but all of the high frequencies get cut off. That's happening. And so when I move that frequency, it basically means more of those higher frequencies come through. As it goes up, you're hearing more and more of that buzziness. Now, and there's another beta that I can control here called resonance. Basically says before you cut off, make this little bump in that frequency spectrum. So let the low sounds through, add a little hump, and then chop off all the high sounds. And so now when I move that frequency, you can really hear this sort of like howling sound. Right? That's what that's doing. And if I remove the resonance, then you don't hear that sort of howling sound. That's what's going on there. But we still don't have our melody. So let's bring that back. I'm going to plug this other cable in. And that's going to go from that MIDI module into the IntelliGel Atlantis as well. And what it's going to do, it's going to send signals that are kind of in between. So instead of just being a binary like on or off, it's going to send kind of in between signals. It'll be like play a lowish note, play a medium-ish note, play a high-ish, right? And so the amount of voltage that's flowing through this cable is going to choose the pitch of the note that's being played. And that gets interpreted using analog logic by Atlantis. And so now we're back, right? Like we've got our melody in. All the other synth things still apply, right? Like we've still got our envelope. We can still make the plucky sorts of sounds or the like longer string sort of sounds. We still got our filter, like cut off the high sounds or the high sound. But now we just have pitch. So that's pretty cool. It's doing its thing. Any questions, by the way? Let me know if you got questions. There's all kinds of like weird stuff we can do. In fact, let me show you one thing. So yeah, there's no sound, right? We're not sending any gate information or pitch information. But watch this. I can start to do some kind of crazy stuff. So I've plugged in a gate, so it's always on. Jump from 0 volts to 1 octave. Yeah, good question. There's a range, and this is a detail that's part of the Eurorack format. Essentially, you can go between -5 and +5. So yeah, you've basically got a 10-volt range here between kind of the minimum value and the maximum value. For trigger or gate type signals, you're going from 0 up to 5, and then for more like audio type signals, you're going all the way from -5 to +. Actually, I think. Well, no. So it depends a little bit. There's some that go all the way from -10 to +10. And the power standard for your rack is -12 to +12. There's a little bit of extra voltage that allows for the headroom. But I think, yeah, I need to go back and check. But CV can actually go all the way from -10 to so what that means then, so pitch, for example, you can have like, lower or higher pitches. The standard in Eurorack and in other formats is 1 volt per octave. So, middle C is 0 volts, and then C, an octave above that, is 1 volt. So, I've now added 1 volt. I've added another volt. I've added another one, and another one. And I can take one away as well. And then pitch works on a exponential scale, but you've got this sort of shape to it. But when you express pitch as 1 volt octave linearly, you end up doing a conversion, right? You end up you end up like doing a logarithm so that you get the correct frequency from that pitch or from that voltage. Cool. Yeah. Now, what that means is that like we can send whatever voltage through this, right? So I could create what's called a low frequency oscillator, or a slow sine wave that has, you know, high voltage and then low voltage, up and down. So I will do that now. I'm going to plug it in here. This is what that sounds like. It's real crazy. Yeah, and I can scale that up and down. So what I'm doing here, I've got volts that are going up and down, and then that gets translated directly into pitches. Now this includes a lot of in-between pitches that you won't find on a keyboard. Like I can't play this on my keyboard, right? It's impossible. That's kind of cool. Like you do microtonal stuff, it lets you do all the in-between stuff. And I'm gonna unplug this for a second. You'll notice that I twisted a knob and it got more intense and then less intense. So what I'm doing is I'm basically multiplying it by some number. And so if I multiply it by a high number, I end up with these really big sine waves. And if I multiply it by a smaller sine wave, then I get kind of like more stable sine waves that are closer to a flat line. And when you convert that to pitch, it basically means you have a really big pitch variation or you have a smaller pitch variation. So here's a really big variation. You're going all the way from like inaudibly high to inaudibly low. And then as I bring that knob down, we're not moving quite as much, it's still a few octaves. And now at this point, it's just a few semitones. And now it's like, it's wobbly, right? But it's probably just a single half step at this point. And that's cool, right? Because again, like this is analog, this is not digital, and so we're able to express all of these. That's pretty cool. Okay, so I'm gonna put this back so we hear straight into things again, and then we're gonna change it from there. Gate. There we go. Yes. This is like one of your simpler patches that you can do. It's basically like the digital is doing all the work. Okay, we're gonna let this thing run its course a bit. Let me transform my audio really quick. Okay, so we've stopped our synth now. Now that we've got that going on, let's go ahead and control the synth from code, which should be cool. I think that like, let me switch over to it. So in order to do that, I like click this little stop button. And so it's easy to kind of visually see what it's doing here, right? Oh, sorry, what it's doing here. We can start to do kind of weirder stuff if we're using code. Right? That's cool. My plan is we're not going to close Ableton. We're going to keep it up. We're just going to we're going to run another program that we write, and it's going to send MIDI into Ableton, and then Ableton will forward it. And that way, y'all will still be able to hear the audio on the stream. And we'll let Ableton like proxy that. Okay. So let's go over to here. I created this like spooky MIDI. So let's go ahead and do this in Node. I think that should be cool. I'm probably quickest in Node. So yeah. So we can say npm init. Let's say spooky MIDI. Sure, version 1. We're stable. We're gonna skip a bunch of this other stuff for now. We'll say MIT. Someday if we open source this, it'll be MIT. And now let's open up the mostly blank folder. Sure, I trust the authors. Close this stuff. And we got our package.json. So we're ready to write some code. I'm going to close this. I don't think we need light blocks at this point. I'm very disappointed in you, light blocks. Or rather, I'm very disappointed in you, Philips Hue. I will have to figure out how to actually stream reliably, like plugged into Ethernet with Philips Hue. Because I know it's going to come back again. So let's see. Let's go over to NPM, and we're going to search for MIDI. And I think, web MIDI. Web MIDI would be fun, actually. Now that I'm thinking about it, I was like considering it earlier. The fun thing, you can actually control synthesizers from your web browser. And there are actually some really great business applications of this. Like you can build like editor programs for synths that your user doesn't have to install. So that's pretty sweet. Twitch plays synth. Okay, yes, now we have to do that. Thank you. Yes, we need to do this now. Okay, what is the easiest way to do Twitch plays synth? So we need to have some UI that everybody can hit, or some API that everybody can hit, I guess. We could just do that, like write a real basic like REST API. I'm going to be lazy and not do WebSockets, but yes, thank you. I like that idea very much. So let's see if this will work. A Node.js wrapper for the RT MIDI C++ library. I think I've used this one before. This is the one. Oh, and I skipped a step. So Twitch plays synth. That's not going to use web MIDI, right? Because it needs to control my synth, like in my room, and so there needs to be some kind of a server where y'all can connect to that server, and it all comes into the same place. So yeah, so I think we'll end up using this instead of web MIDI. That should be great. So let's go ahead and try this. Install some MIDI, and it's actually got native code under the hood. So yeah, it looks like it's going to compile that. I'll let it do its thing for a little while. And I would like to just copy and paste some code. So let's just grab this. And let's say source index.js. There we go. So the main is actually there. Start is going to be node source index.js. Let's see. We need to be able to get port count equals that. Oh, we don't have range. Dang it. We have to. Okay. I have to write a boring for loop like a peasant, because JavaScript doesn't have it doesn't have a built-in range function. Is less than port count port count plus plus. Okay, got that. And then we should be able to do this. Port IDX. Port name equals that. Console log port. And let's see, output port. And let's not do this just yet. Let's just see what ports are available. I am not really sure what we will see. What? Assignment to constant variable. Oh, whoops. This should be port IDX plus plus. Thanks, type system. Okay, IAC driver bus 1. IAC driver IAC bus 2. Scarlet 18 I8 USB. So this last one is the one that we care about. This is the one that is actually like plugged into my synth and the Ableton is controlling. So this is the one that we want to connect to. Let's find out. So I'll say MIDI port name. I'll save that here. And I'll say if port name is equal to that constant, then that's what we care about. So we'll create a run function, and inside of run, we'll have another one that is get port, and we'll grab of this. So we'll say port equals get port. Then we're going to say, oh, how do we? Oh, then we should return output, I guess. Open port. Yeah, this API is kind of funny, isn't it? Like, I guess we just have a reference to output, and that's it. I guess we could do like get port IDX. Do that. And then if we get to the end and we haven't found it, then we're going to throw an error. Okay, so we'll get that. And then we're going to do a little bit of the work all over again. But like, not much. Port IDX. And then, yeah, we don't want to close the port just yet. I have no idea what message that is. Let's just see if we can open the port. Console.log open the port. And I'm curious, like, will we be able to open the port at the same time as Ableton, or do we have to close one in order to open the other? Open the port. Okay, it did it. So that's pretty cool. You know what else I'm going to do right now? Oh, I can't connect to the lights. There. Okay. We're just going to turn those off for now. They're not contributing anything. I'm so disappointed in Philips Hue. I can't believe it did that. Yeah, whatever. Hey, for everybody that's joining, welcome. I'm Andrew. This is Code Gets Creative. If you've tuned in previous sessions, you might have seen Screeps. We're taking a break from Screeps today, and we were doing spooky, scary, spook alley stuff. So we were doing some synth stuff, and what we're doing right now is generative music. So we're writing a little bit of code to control the synth, and in a second here, I'm going to send out, like, once we've got a workable server, I'm going to send out the link. So then everybody can make it do crazy things. Okay, so that's what we're doing. Welcome. Thank you for hanging out. So let's see. We need to figure out some messages. Is there not like? Here we go. Status code 144, which means node on channel 1. All right, we're going deep. Done this before. I was kind of hoping we could get this stuff for free in a library, but whatever. Reference tables. I think we want this. Oh, it's in binary. Good heavens. I don't want to convert binary to hex or to whatever. Maybe this isn't that bad. I'm just being super lazy here. I thought of one other thing that I think I should do at this point. And that is like, let's get the like normal tunes back on, because we're going to be writing code for a little bit. There we go. Turn that up a bit. Let me know if the volume is too high or too low. Wait, is that on shuffle? No, it's not. We caught it. Sweet. Okay. Things are returning to normal. So we're able to do all this. So MIDI message with status code 144 is node on channel 1. Let's figure out why that's true. Binary calculator? I think Google can actually do this. 144 to binary. Yeah, here we go. Okay, so 144 is node on channel 1. So if we come over to here, note on is 1001, and then this. What is N? Note is the press start. A is the key, or note number, and V is the velocity. So it's like, so you send this, which is like, hey, there's a note on for this channel. It's this pitch. Yeah, it's this pitch, it's this velocity. That's cool. 1001, all zeros. Okay, so the channels are zero based. That's what that means. Okay, sweet. So we should be able to do that. Um, 144. And then it's pitch after that? Yeah. Now, and if I remember correctly, pitch 69 is middle C. Is that right? It's probably somewhere buried in here. Yeah, we can just start like somewhere around there, and we'll see how high or low it is, and we can adjust. And then this is velocity. Now, my synth actually, like, I don't have stuff routed out of my synth to do anything with velocity, so we're just going to do 100%. Okay. So now we need to actually like play a note and then stop playing a note. So let's see, we will run, and then we need to like await pause for like 500 milliseconds or something like that. So let's async function pause. I write this function like all the time. It's crazy. return new promise, resolve, set timeout, resolve, milliseconds. So what this basically does is it says like, wait a certain amount of time, run, like execute this named function after this amount of time. And so the purpose of this function is to resolve a JavaScript promise. So that's what that's doing there. And it basically lets us convert between the promise-based world and the more modern async await world that we want to work in. So that lets us say await pause for 500 milliseconds. So then we should be able to say note on, and we should be able to say note off, which should be, let's see, note off is this. Okay, so what if we do, I just need to change this 1 to 0 here, 128. Hey, look, this is a calculator. Okay, and I think, yeah, note off like has a velocity, but it doesn't really mean anything. So that's cool. All right, VLC, let's see if this thing worked. And we'll close the port like good citizens. Hopefully y'all heard that. Yeah. Okay. So we're making progress. So if we wanted to, we could throw together a very boring 16 note sequence like this. So we're on for half a second and then we're off for half a second, and we're going to repeat that 16 times. It's going to be the same note every time, but like whatever. Five, 6, 7, 8. It's working. And then 16. And then it finishes. Okay, cool. So that's great. Another thing I want to point out, so I'm going to run this again, but I'm going to tweak my synth, and you'll notice that like the digital messages are only telling it what note to play, but the synth itself and like all of the analog knobs and switches and stuff tell it how to play that note and like with what tone. Yeah. And it just finished. So that's cool. You'll notice that halfway through the octave drop down, that's because there's an octave selector here. So it's basically like adding and subtracting 1 volt at a time to whatever the input is. But what that means is that like we don't have to be too particular about like what notes we pass in, because like this can transpose it just fine. It can shift it up and down just fine. Okay, and so now Crasula rupestris. I wish I knew like properly how to pronounce your name, but it's a great one. So yeah, they said Twitch plays synth ? So we need to make that happen. That needs to be a thing. So here's how I think we can do that. We need a server, and then we need some like thing that the server does. So let's see. My favorite like very simple server is Express.js. And maybe some of you have used Express.js as well. If I go over here, there are some cool guides. Let's just start here. Installing. So we're going to go ahead and say npm install Express. And that'll do its thing. And then here's some boilerplate. And I will move my requires together. Oh, hey, I got to turn off light blocks so that we're not colliding with the port. Okay, so we'll do that. Also, let's get our beats back on. Yeah? Yeah. All right, good. Got all that. Listen. So let's see. The way that we want to do this now, I'm gonna rearrange some things a little bit. But essentially, this all needs to go inside of here. And I think app.listen, yeah, app.listen should just block forever. So we'll never actually hit this line. But what this does is it says, hey, go ahead and create my app, start listening on port 3000. And then whenever we hit this endpoint, then we should be able to, return hello world. So that's that. Now I'm gonna comment this out. We're not actually going to play any notes yet. So let's just test this for now. So if we say npm start, oh yeah, lowercase port. Try this again. Okay, cool. So we have that. Now that the server's running, I should be able to make a request to it. So if I say curl, show me the headers, HTTP, localhost, port 3000, and we want the index, right? So go ahead and make this request, and it says 200 response. It worked, and it says hello world. So that's perfect. It did the thing. Okay, so now let's make it actually do a synthy thing, right? Let's grab, I'm gonna make this like a shorter note. Remove that. And I'm gonna say, yeah, res.send. Yeah, that'll be fine. Basically, I want to do all of this after the. It's a little loud. So I want to do all this work after the. I like lost my train of thought from this beat. Sorry. It's a great beat. I think this is a Bad Snacks. Yeah, frustrated by Bad Snacks. Shout out to Bad Snacks. She's really cool. Check out her YouTube channel. This is all like royalty-free. Bad Snacks, Noir A. Blanc V, and Sarah the Instrumentalist that you hear on this channel. So thank you to them. Okay, so what this should do, we should see hello world, and then our synth should actually play. So I'll restart the server. Oh, await is only valid in async function. Fair enough. Okay. So now, did it play? I don't think I heard it do anything. Let's okay. We're gonna come back to this in a minute. I should send this somewhere that's like convenient to get to. Sure. So it claims it happened. Okay, so we have sound. That doesn't seem to be doing anything though. I want to say that res.end is actually a thing, which basically means like it should end the request and then keep doing work. Yeah, but that's not doing anything. So I'm not sure what's going on here. I'm gonna try doing this really quick. I'm just gonna like send one message before you even start the server. Okay, so we have our server and we have our synth, and now, yeah, still nothing. Still nothing. And I want a new line after that. Wait, go back. Yeah, like I'm doing that. Let's see, what is going wrong? Finish the note logic. I assume we should be able to see that. Yeah, finish the note logic, finish the note logic, finish the note logic. So like that's, I mean, we're hitting that line, so we should be hitting the lines above it. So let's see, what else do we need to do in order to make that work? Is this line actually getting hit? It could be. Yeah, closing port. Okay, that's got to be our problem then. So somehow we're actually hitting that line. I wonder, what does this return? It returns a server? Yeah. Oh yeah, it returns a Node HTTP module server. So what if I just do this? I can run this. Ah, there we go. Okay. So we just need to make sure it doesn't. Yeah, do that. Okay, so I was wrong. I thought that this statement would just block forever. And clearly it doesn't do that. Like what it actually does is it tells Node like, hey, please don't go to sleep once this function is over. Like stay alive, block sigterm or whatever else, and like keep the server running until like Control C happens. So okay, that should be great. We can do this, and we can have a good time like doing this all day. Let's get the like tunnel working now. So what I'm gonna do, ngrok. Do I want to use ngrok? I should use my own tunnel. I can't remember how though. Oh, maybe I can figure it out. Create tunnel. How does this work? Create tunnel with a port number. Oh, nice. Okay. Create tunnel 3000. This is connected. So if I do curl tunnel.andrewjensen.io. Nice. Okay, that works. Boom. And let's pause this. So I invite you all to run this curl command. You've seen what it does. But yeah, it will. There we go. Testing now. Nice. Which plays synth. Yeah, we got some notes. Thank you for participating. So the thing that makes this possible is a TCP tunnel. So you'll notice that I ran a command over here called create tunnel, and what that's actually doing. So I'm going to break the tunnel for a second. What I'm doing, notice how I'm running a program called FRPC. And let me look that up really quick. FRPC GitHub. This is a really cool program. It's fast reverse proxy. But yeah, basically what it lets me do is it lets me expose HTTP ports and TCP ports on my laptop to the entire world. As long as the tunnel is running, right? So when people watch the YouTube video of this in the future and they try to curl this, it's not going to work unless I have like something else up at the tunnel, which like, sure, maybe I will. I intend to use this tunnel for like testing and kind of sharing temporary links to people. So I'm not like worried about the link like getting out. But this is hosted on my website. And you can host it on yours too if you're interested in that kind of stuff. So if I run the tunnel again, then I can keep making those curl requests, and so can you. It's pretty cool. Hey, thanks, whoever that was. Yeah. Okay, so now that that's working, I've killed the server, so it's not going to respond for a minute. And I think actually, if I do this again. Oh, this will not reconnect. Okay, so I'll do it that way. I'll kill both and then restart both. Okay, let's make this a little more interesting. How do we want to do Twitch Plays Synth? What interesting things can we do with that? One very like synth wavy thing that we could do, like. Sometimes synths will just like, I'll prototype this out. Or no, I'm going to say while true. And then I will say, do this stuff. And so that'll just loop forever. But this is going to be a very like synth wavy sort of sound. Except, oh gosh. There, okay. What just happened there is that I killed the server in between the node on message and the node off message. So the synth never received the note off, and it was like, cool, I will dutifully keep playing that note forever. Okay, so we had to like restart it and clear it out and like time it right. Okay, so we want that to be faster. If it's 120, I want 16th notes, so it should be like 125, I think. Just double time that. Yeah, it's starting to get a little more synth wavy. I'm gonna tweak the tone over here. Oh. So, okay, so we've got like a cool tone now. It's not low enough though. So let's say 60, we want to go down 2 octaves. So 60 minus 12 notes times 2, right? So we're going to go down to 36. 36. And let's see how synth wavy this sounds. Oh yeah. Much better. So this is starting to sound a little bit more like a track. So now what I want to do is turn that off. I want to allow other people to control what note it's currently playing. So let's say, let's clean this up a bit. Current note, current pitch equals 36. Okay. Let's see. So that's all happening. So I think what we could do. We'll never. So this actually does block forever. So what I'm thinking is let's start the server here. And then let's create our baseline right here below it. So we'll block forever. So I'll say console.log starting up the sequencer. Okay. And then right here, we're gonna pass in the current pitch. Wait, no. We're gonna remove this from here. So actually, like, calling this endpoint is not going to it's not going to like directly trigger the synth. Basically, the synth will be constantly triggered, but will allow the user to change the note here. And I want to add a little bit of constraints here. So let's see, 36 plus 12 is 48. So I'm going to say new note. Now, and we're going to keep this as a get method rather than a post method, just because it's a little easier to manage. I'm going to say thank you for your note. New note with a new line, and we need to grab that new parameter, which I think should be a little further on in here. Static files, more examples. Basically, I want to show parameters. Rec.params. Yeah, here we go. We want to be able to say like user / some kind of ID. And then rec.route gives us this whole thing. Wow. Is there a rec.params though? I thought there was. Yes, I think that's what I want. New note equals rec.params.new note. That should do that. And then we should be able to say current pitch equals new note. Oh, so let's actually call it, let's call it new pitch. Okay. Let's see if it works. Oh yeah, and I like I mentioned, I wanted to add some more constraints. So if new pitch is greater than or equal to 36, and new pitch is less than or equal to, what was it again? 48. Then we will do it. Else we will say sorry, that pitch is out of range. There. So that'll please choose one between 36 and 48. Okay. Let's scope this a little bit. I'll call it API pitch, new pitch. Yeah. Here comes the curl request in just a sec. But now that's doing its thing. And I'm gonna start up the tunnel. API pitch. Let's see. Let's go 39. So we'll go up a minor third. It didn't work. Did we do something wrong? Oh, I see. We need to replace this part. I think I replaced it somewhere else, and then I forgot to, I replaced it somewhere else, and then I deleted that other place. That would do it. Or rather, that would not do it. Okay. Yes. Let's see, 36 plus 7 is 43. And we're playing a synth. Stopped. I think I know what happened. So there's a problem here where suppose that a request comes in right here. If a request comes in this fraction of a second where we've already committed to one note, but then we change to a different note, and then we send a note off for there, we're going to hold this earlier note forever. Which actually, there it is. It's like still going. Oh. Could you show the code? Sorry about that. I've been like not showing it this whole time. Okay, so thank you for that. Yeah, okay, so let me do that again really quick. There we go. Okay, so we're back in a normal state. So we're playing our synth, right? It defaults to this 36. Okay, sounds good. But it just happened again, right? And so the reason for that is because if we've got one note up here where we send our note on message, but then we've got another one for our note off, then it's like, cool, I'll stop playing that note that I wasn't playing before anyway. But like you haven't told me to stop playing that first note, so I'm just gonna keep playing it. So there it is. So I think what we need to do is note to hold. Like let's just like create a copy of it. And so this is stable. Like we've now made a copy of it that is not going to change for the duration of this loop. This iteration, I should say. This is really cool. Like this is stuff we have to think about with concurrency. Good for us, I guess. Let's try it again. And we're back. And then I want that 39 again. Yes. All right. And now I need help from all of you. Oh, and you know what? I would like to be able to see this in the logs. Let's see. Let's say console.log new pitch. So now if we do this again, then we can see this come through. And that's useful because like I want like when you all try this, I want to be able to see that like stuff is changing. Okay. So I grab this and here it comes in the Twitch chat. So go ahead and try running that. And then remember that very last number is a path parameter, and so you can change it to some other number. Ah, 41. An excellent number. Another good number. $45, $43. Oh, and a sudden like burst of them. I would love to know if somebody is working on like scripting this. Okay, that's starting to look like a script. My listeners are doing crazy things. I love this. Thank you all. Yes. Oh yeah. Okay. So yeah, again, like here it is in the chat for anybody that's joining. I'm gonna just goof off with the synth for a couple minutes. Like y'all keep like everybody else choose the notes and I will just change the tones. Maybe I'll do this. Teamwork. This is very deranged. I love this. Is this the future of music? Maybe. I'm pretty sure this is how music gets made in 2021. Like, people get together and they just like send curl requests to each other's MIDI servers, and music is made. Like this collaboration. It's a big thing. What is this? Somebody just sent me a crazy thing. A reliable piece of evidence has come in that makes me think that a coworker is trolling me right now. Thank you to my trolling coworker. I love this. Okay. Yeah, this is pretty outrageous. There we go. We're back to the computer world once again. So, okay. I think we're about out of time for today. This has been a very good time. Ooh. Got a new flurry of messages. Thank you. Thank you for your contributions. I think we're about out of time for today. This has been a very good time. It's been very silly. Turn this up a little more. Yeah, thanks for everybody tuning in. This has been a very silly time. And we've come full circle now because we've got the Stranger Things theme being sent to the server. Thank you. I heard it in there for a second there. Oh, yes. Appreciate everybody hanging out. There it is. There it is. The future of music, everyone. Oh, man. All right. Well, I guess I got to do the slow fade, right? Gonna slowly do that. Well, thank you to everybody that tuned in. I'm Andrew. This is Code Gets Creative. This was a very good time. And yeah, see you next time.